Yeah, I'm just, there we go.
Okay, thank you very much. Colleagues, friends, welcome to the next edition of SEGH Fellows Live. My name's Andrew Hursthouse, and I'm going to moderate today's presentation from Alikos Dimitriades, who is a well-known supporter of SEGH and contributor to these presentations as well. So it's really good to have you on this Friday afternoon. Bit damp in Scotland, but I'm sure around the world we have every single season represented. So without any further ado, I'll let Alikos start. What I would like to ask is everyone keeps their microphones on mute until we get to a point at the end of the presentation in perhaps about 40 minutes time to offer some questions, make some comments, and get some discussion, and a really sort of stimulating title and abstracts on the SEGH website for today's presentation on agricultural and grazing soil and food production. I won't say any more than that, and I'll let Alikos take the floor, and welcome to this afternoon's presentation.
Okay, thank you. Shall I share the screen now?
Yes, yeah.
Well, let's see if it works. Can you see it?
And see the presenter's view, not the presentation. That's
Can you
it
see
now.
it?
That's
Okay.
great.
Okay. Right. So essentially, since we have some young researchers as well, of course, we have senior researchers as well, I will go through the stages, and then we end with the results. And the most important results will be for the soils of Ukraine, where we have problems. So the GEMAS project objective, it was to produce a land use related geochemical database needed at the European scale for the REACH regulation by the companies of the European Association of Metals. Now, the REACH regulation addresses the production and use of chemical substances and their potential impacts on both human health and the environment. Now, the Eurometals companies submitted their dossiers to the European Chemical Agency for examination and approval. This is after we have given them the results, of course, and they process them. And because they had to prove that their chemical products imported or produced do not present any risk to human health and the environment in their use in agriculture and animal rearing. Now, the first step in such a pan-European project, it was to secure the participation of the countries, the European countries. We managed to have 33 European countries, which you can see on the map on our right-hand side. How can I, just a minute, lower? Okay, that's good. Now, these are the logos of the partner, let's say, geological surveys, companies, universities. In total, about 72 scientists participated in the GEMAS project. Now, if we count the supporting staff as well, it should be more than 100 persons, and probably we reach almost 200 persons. Now, the development of uniform and homogeneous pan-European geochemical databases demands the standardization and harmonization of all procedures, namely, vital sampling equipment to be purchased centrally and distributed to all participant countries, sampling procedure to be tested in the field before finalization, and the compilation of a field sampling manual, preparation of 2 large reference samples, agriculture and grazing land soil, sample preparation of all collected samples at the same laboratory, randomization of samples and insertion of quality control samples, chemical analysis of all samples to be performed by exactly the same methodologies and at the same laboratory, and upon receipt of the analytical data sets, their quality is first verified and a quality control report is compiled. Encounter problems must be reported and the solutions given in the reports. So we started with a field and a kickoff meeting in Berlin, in Germany. And this is where we're going to sort of solve all the problems before the start of the project. Now, the field manual was written in the office. And here Clemens Raymond is reading the instructions from the first draft of the field manual. And Tore Volten, as you can see me here, is ready to follow the instructions and carry out the sampling. Now, the sampling scheme was a 10 by 10 meter square, and we collected samples at each corner and the center. So 5 subsamples were collected and placed directly in the resin bags. I will explain in a minute what they were. And also we had to put a Ziploc strap immediately after collection, and I'll show you that in a minute. And the resin bags up to the half mark, they hold about 2 to 2.5 kilograms of soil. Now, duplicate field samples were taken at every 20th sample site. Of course, we use the same plot of land, but at different sites. And countries that had sample sites less than 20, they had to collect at least 1 duplicate field sample. And here is the resin bag, the number. This is the flip number thing that we have in order to automate the sample number. And here GER is for Germany. This is the number, and AP represents the soil, the agricultural soil, and GR will represent the agricultural soil. Now, here is the resin bag. This is the small pack and the small card where we write the number and place it in the bag and close it very securely. And this little number card is placed on top of the sample, and it continues to be with the sample during the sample preparation. Now, this is a safety precaution. And here Tore has collected the sample. Okay, and here is in the bag. Here is the little card that you can see it is there in the bag. And this is the strip lock that we use. And you cannot open the bag after it is closed. So the condition was that if any bag has been tampered with, that the Ziploc has been removed, then that particular soil sample is thrown away because it has been sort of handled before the reach of the laboratory. Now, something very important, every sample site is documented by at least 5 photographs. The first photograph is the sample number. Then we take the site photograph with natural light and also with fill-in flash and a general view. Of course, you can take more photographs if you wish. And most importantly, we had to follow the same order, especially always take the first photograph the sample number. So all the succeeding photographs belong to that particular sample site. And this is the grazing land soil. Again, the sample number first, natural light photograph, fill-in flash. Here we had to take a close-up also of the vegetation of the grassland, and we have a small card which is 20 centimeters, so we can, it's our sort of ruler in a sense for sizing. And also we take a general view photograph and more photographs if we wish. Now the field observation sheet is very simple, as you can see on the left, and is completed on site. And also we have a map whereby we mark the 2 sample sites before we leave the sample site. And something that we have added afterwards is that we take a photograph of the field observation sheet just in case something goes wrong in the field. Now, we had another option. If you are online in the field, then you can use either a topographic map or Google Earth, whereby you can mark the site. As you can see, that was the sample site here in Hellas, and you can see the tree in the photograph. And again, you take the photographs, and also you have a general photo of the site around the sample site. And in this case, since you use the laptop or the smartphone, you have to back up every evening all the observations and photographs. Now, important cautions we had, because we were going to analyze silver, gold, and platinum, they were not allowed to wear any jewelry or rings when sampling. And it was very important that this little note has been taken care of. We stress it many times. And of course, because we know that some of our colleagues smoke in the field, smoking is not permitted during sampling. And something that it was very important from the beginning, because there were going to be a lot of people participating in the GEMAS project. The data were free. Anybody can use them to write a paper and also to have co-authors that help him in help the leading author. So the arrangement or the agreement was that the leading author and the co-authors were on the top, as you can see there, but all the members of the GEMAS sampling team are mentioned below on the first page of each paper. This was a difficult thing for the publishers, but we had to force them to accept our conditions, and up to now had no problems at all. Now, this is the field manual, which you can download. And here was the equipment that was centrally purchased and distributed to all participants. That was the certified trace element-free resin bags, strip locks for the sample bags, a scale bar for the surface photographs, the small card, and also the Ziploc bag as well. And the black permanent ink markers were all purchased centrally again and distributed to everybody. Now, the equipment that had to be purchased by each country and for each sampling team was stainless steel or steel spade. And if this was painted, the paint to be removed by sandblasting. The same applies to stainless steel or steel mattock cutter, stainless steel saw knife, field observation sheets, the GPS for recording the sample coordinates, topographic maps 1 to 50,000, digital camera. Nowadays, the smartphones are much better than 5 megapixels. Plastic or heavy-duty cardboard boxes for packing the samples. Now, these are the sample site maps. We collected 2,108 agricultural soil samples and 2,024 grazing land soil samples in 33 countries, and we cover 5.6 million square miles. Now, sample preparation and laboratory analysis. All samples were sent to Slovakia, and they were prepared at the State Geological Institute of Dionysus Sture. And here is the procedure that we followed. They were dried at 40 degrees, disintegrated, homogenized in porcelain bowl, sieved through a minus 2 millimeter nylon screen. Then the size fraction 2 was mixed, homogenized, and then split. We had 6 liquids, of different volumes for analysis. And also we had another 4 bottles, 200 ml each. These are the reference samples which are nowadays kept permanently stored at the British Geological Survey storage facilities. This is the analytical program. As you can see, we have almost analyzed the whole periodic table. And the analytical method that the REACH regulation wanted was aqua REACH. So after a tender, because we had a condition that all analytical results must be given to us without cutting at the laboratory's lower detection limit, even sub-zero values, that is the reported values that they come out of the machine. Not many companies were willing to do this. I don't know why, but anyway, with ACME, we managed to do this. So they won the tender, and they analyzed the samples. And of course, we had another condition. I think this was the probably more strict condition, that we had to verify the quality of the analytical results before payment was made. The PKR analysis by XRF were free. The SGS analysis by the coal mobile metal ion solution, again, was free. The Geological Survey, again, free analysis for pH. Geological Survey of Norway also has analyzed carbon, sulfur, and lead isotopes, magnetic susceptibility, soil color on dry, wet, and wet samples. The Geological Survey of Slovakia analyzed, determined, the cation exchange capacity. The other, FUCRO, we paid the total organic carbon analysis and the grain analysis, and they did not do it a very good job. And this is reported in the second quality control report. Then we had free analysis for strontium isotopes. Again, free analysis for total carbon, nitrogen, and sulfur on the agricultural soil only in both cases, or in the strontium isotopes as well. Then the Kazan Federal University in Russia determined magnetic measurements. And then we had 0 in Australia to determine the partition coefficients for silver, boron, cobalt, copper, molybdenum, manganese, nickel, lead, antimony, selenium, tin, tellurium, vanadium, and zinc by infrared diffuse reflectance spectroscopy. These were paid by the Eurometex companies. And also, it was possible to estimate other parameters. Now, the quality control that we wanted was originally to use a duplicate, the balance ANOVA, but unfortunately, because the sampling equipment, the sample preparation, the aqua REACH analysis, and some other analysis exceeded the amount that we had, we finally ended in using an unbalanced ANOVA design. Now, this is for the young researchers. The quality of laboratory analysis must be first verified, and you never start processing the laboratory analysis before their quality is verified. Now, this is one of my favorite slides. Sampling and sample preparation are two very crucial stages of any geochemical survey. Any errors during these two stages is carried forward and can result in the failure of the whole survey. And if you are in a private company, you can get fired as well. Oops. Now, with respect to laboratory analysis, errors can be collected by the analysis of samples, provided enough sample material is available. This is the first the quality control report for the Aqua Rich analysis. We had to do this in a month in order to pay the Acme company. This is the second quality control report. It was for total carbon, sulfur, XRF, TOC, CEC, pH, and particle size distribution. And this is where we had wrong things done. And they are reported because it's important for everybody to know where everything went wrong. And this is the third quality control report for particle size analysis by the mid-infrared spectroscopy, lead isotopes, the mobile metal ions method, quality control of the project standards. And for the MER, there was collaboration between BGR and Zero and ARCH for the development of European mid-infrared model. Then we had to do the data processing, map plotting, interpretation, writing of a book chapters, and publication of a 2-volume atlas accompanied by a DVD with data files, maps, and diagrams. Now, so as you can see here from the numbers, there were, there were many maps plotted. In fact, on the DVD, there are 2,234 maps. So it's a lot of things to study. These are the printed volumes with the accompanying DVD. Now, the agricultural soil samples were analyzed by 3 different analytical methods, whereas the grazing land soil samples by 2 analytical methods. This is just to show you the results of we had the hot aqua richa, total XRF, and the cold mobile metal ion extraction, which is very good for agricultural purposes as well. But the REACH specification specifies hot aqua richa extraction. Now, I cannot resist to show you that you see here the patterns are the same. Of course, the levels are different. And here we have the grazing land soil by hot aqua richa and total XRF. Now, there are substantial differences in the median values of the country median values. As you can see, we have here the Slovakia, where we have, this is lead, and in Finland, we have a very low concentrations in lead. This is nickel. So here we see the countries that have mafic and ultramafic complexes have the higher median concentrations, and the ones that do not, they have the lower median concentrations. You can see there is a trend. Now, geochemical patterns of 2 different sample media are robust. As you can see here, we have the agricultural soil 0 to 20 centimeters and the grazing land soil 0 to 10 centimeters. And as you can see, we have 2 different sample media, but the patterns are almost the same. This was something that we knew from the Forex project as well. Now, the impact of geology, or rather lithology, here we see the where the carbonate sediments are. And as you can see, the calcium maps the carbonated consolidated rocks quite well. The last glacial sands, where we have here, as you can see, they are very nicely mapped by silicon. And also the central European loess belt, you can see it very nicely mapped by zircon. And we have the Italian alkaline volcanics, which are very nicely mapped by zircon again. This anomaly here was a surprise to us, but after a thorough investigation, what happens is that the eruptions from Italy, because the winds were blowing in this direction from southeast to southwest, to northeast, there was the signature of the Italian volcanics in Croatia and Montenegro. The impact of climate. Here we have elevated sulfur contents near coastal areas and also organic material. Elevated selenium contents showing strong coastal effects, as you can see here, and of course Ireland and southwest England. The impact of human activities. Now you'd be surprised, you can see on this mercury map London, Paris, Brussels, Amsterdam, and again on both maps, mercury in agricultural soil and grazing soil. And something that we did not expect, gold. As you can see, there is an anomaly of gold in London area, and we did not collect any samples in London, but also in Paris and Amsterdam. And also you can see this even better with the MMI, because the MMI analytical method was for mineral exploration and especially gold. Risk assessment. We have the risk characterization ratios here. As you can see, there is a slight difference where we have one, okay, between the agricultural soil and grazing land soil. And you can see the percentiles down at the bottom of the table. And here we have copper. And from what we have seen, the let's say the risk areas where the red areas where they're shown, the samples were taken in vineyards or near vineyards. So because they use copper agrochemicals, this was found in the analysis. Now, health implications. Most likely, you all know this. We have the dose response curve of elements showing the narrow safety range for sustaining plant, animal, and human health. So everything has to be, let's say, balanced. And here I show you something that was very interesting. When I seen it for the first time in another publication, we have the red line shows the blood concentrations. Okay, the European topsoil is shown with the triangles. You can see the patterns; they follow very nicely the blood concentrations, and also the European groundwater. Of course, we also have the upper continental crust as well. So we are, let's say, we depend our chemical, let's say, makeup is closely related to the materials of the earth crust. Hence, everything that should be in the correct proportions in the soil in order to have healthy food and healthy health for ourselves. Now, here we see the Lazio region with high arsenic values, and also Cornwall in both grazing land and agricultural soil. Of course, Massif Central with high arsenic in soil is because of the young volcanism, gold and lead zinc deposits. Now, something that we stress is that element deficiency needs more attention. And as you can see here, we have a lot of the area, about 10% of all values are less than 5 milligrams per kilogram copper. Because we know that copper deficiency is linked to anemia, osteoporosis, thyroid problems, low body temperature, etc., these areas have to be looked at by medical people and also SEC people as well, if there are any problems, health-related problems in this area. Magnesium deficiency is linked to some types of cancer. Again, we see large areas in Europe for both for agricultural soil and grazing land soil with values less than 400 milligrams per kilogram. Selenium, here we have toxicity. In this case, is in Ireland, we have high selenium, and this causes selenosis in cattle and horses. But we also have a lot of areas with not so much selenium, so this area have to be looked at. Zinc, again, at least 5% of sample values are less than 12 milligrams. And as you can see, we have a lot of areas with that have concentrations less than 12 milligrams. And of course, we know that symptoms of zinc deficiency include poor plant growth, loss of appetite, anorexia, and decrease in immune function. Now, this is all this data are new, and we have processed this data because of the Ukraine. And I see that Philippe Negrel is online, and we are in contact with our Ukrainian friends and colleagues that we should do a follow-up when the war stops. Here is a 2014 report from FAO, and if you read let's say the introduction, they say highly favorable agricultural ecological conditions and an advantageous geographical location give Ukrainian agriculture its competitive edge. Ukraine is renowned as the breadbasket of Europe, thanks to its black soils, Chernozem, black because of the high organic matter content, which offer exceptionally agronomic conditions. 1/3 of the whole world stock of the fertile black soils, which cover more than half of Ukraine's arable land, a large variety of climatic zones, and favorable temperature and moisture regimes, offers attractive conditions for the production of a large range of crops, including cereals and oilseeds. Now, this is the black soil regions in Europe, and we see that the largest part is in Ukraine, in Moldova, in Romania, and also there comes down to Bulgaria, Romania, also in the western part, Hungary, Slovakia, Czechia, and small patches in Germany. Here is the general view of one sample site, in Ukraine, and the profile. Now, as you can see here, both the agriculture and the grazing land soil are in the region of the loam and silty loam and loess. Okay, so this is really good soil. And here we see the total organic carbon. You can see it's quite high in the samples. This is the agricultural soil sample. This is the grazing land soil samples, again, high concentrations of total carbon. And something that our Australian colleague has done with the cold mobile metal ion extraction results, he made a micronutrient index by multiplying copper, iron, cobalt, molybdenum, manganese, and zinc. And this is for the plants. And as you can see, the areas where this micronutrient index is highest. And a macronutrient index as well by using calcium, potassium, magnesium, phosphorus, and sulfur, and dividing by 10 to the 9th. And you can see again the results where these are the highest and supposedly to the best soils. And also he calculated a mobility index using aluminum, iron, and titanium, which means that these soils are let's say the sample sites you see are the best for mobilizing the elements. And now the problem. Here is what we have now in Ukraine, missiles. And here is a map, a photo image, where you can see they have estimated that at least 90,000 tons of soil have been upturned, and there are tons of mercury, lead, arsenic, iron, copper, and sulfur added. And these substances are incompatible with growing wheat. This is according to the soil scientists, the farmers, and the grain companies. And the problem is that what they say is that the global food supplies could suffer for years to come because this contamination or pollution, we may say, it will take a very long time to get rid of. So the big question is, what should the European leaders do to safeguard the Ukrainian black soil region? Now, we had a black soil project. It was an IGCP project. It was led by the Shenyang Geological Survey in China. It ended last year. And we were asked to participate as a commissioner of the International Union of Geological Sciences. And we have written a manual for sampling black soil according to the specifications of the Global Geochemical Baselines Project. Now, these are the black soil regions, and as you can see, they are much more extensive in the northern hemisphere. We have from China to Europe, and also we have the Canadian and the United States regions. There are smaller regions in South Africa, South America, sorry, and in Africa. Now, this may interest you. All the maps are placed on a periodic table. Each element takes the place of a different chemical element. You can download this from the GEMAS website. And also we have mineralization and mineral deposit maps as well. Now, our data gaps, mineralogy is missing and organic compounds are missing. Now, the GEMAS atlas results can be used for effective land use planning, that is for agriculture, grazing land, mineral exploration, land use policy, health-related research, environmental policy, constructions of new towns, and many other applications. Now, something for the young and early career scientists. The most important components of collaboration for the effective and successful implementation of such multinational continental-scale applied geochemical service are transparent cooperation, communication, assertiveness, autonomy, and at the same time responsibility and accountability, dedication, mutual trust and respect, and last but not least, coordination, prudent and ethical leadership. As Narsen and Al pointed out, without trust and respect, cooperation cannot exist, assertiveness becomes threatening, responsibility is avoided, communication is hampered, autonomy is suppressed, and cooperation is haphazard. Now, the main job of the applied geochemist is to ensure that the field and laboratory procedures, sample preparation, and chemical analysis are applied correctly and the produced data are of high quality and integrity. That's our main job. Now, interpretation of the results is completely another matter and depends on the training and experience of the applied geochemist. So thank you very much. Here at the back of the references and also the GEMAS publications, all of them can be downloaded from this pCloud hyperlink. This is for your personal use. You can visit also the GEMAS project website where you can find more recent information, and also the backyard GEMAS portal has the maps and also data which you can download. Okay, that's it. Thank you.
Thanks a lot, Alikos. That was an outstanding review of quite an awesome program of work, and really nicely detailed in sort of outlining the key points of sort of engagement when you're carrying out large scale projects. And I guess from my perspective, we from the academic side, we normally look in terms of short-term projects with quite small numbers of pairs of hands, as opposed to the enormous mobilization of resource that took place here. So I guess the detail of the collection and generation of data sets of that magnitude is really something that from the academic side we can only look at with some degree of amazement, envy, or whatever. But sort of from your experience, and you pointed that out at the end, I think, which was quite nice, the sort of key points that perhaps an early career researcher with only themselves as a resource and their supervisors, what are in undertaking, say, environmental geochemistry type research, what are the main top three sort of things to worry about, if you like, starting out with a much smaller scale but similar type of study?
Well, dedication. Dedication, that also a lot of hard work. Okay, yeah. I think this is the important thing. And I mean, even in small teams, you have to work as a team. Even a two-person is a team. So all these things that we have said at the end, it goes also to a two-team person or three-team person. They have to be honest and share everything. That they should not keep anything for themselves. And this is it. The integrity above all.
Excellent. So, colleagues, is there anyone who wants to ask a question? If you want to raise your hand, I'll try and see who I can see. Ariadne.
Right.
Hello.
Hi.
Sorry,
Hello.
no camera again. But can you hear me okay?
Yes, perfectly.
Okay. Thank you very much, Alekos, for another very detailed presentation of this huge work that it is done by Eurosurveys and the Commission of Global Geochemical Baselines. I would like to ask you, do you think these protocols, the same protocols that are now very detailed and very well documented in these reports, can be applied when we start working on emerging contaminants? There are things like organic chemicals, and there are things like even microplastics and nanoplastics in soil that people are start looking into. Do you think that it's a good guidance also for these people, these protocols, of course, with the appropriate adaptation, I guess, but how far they can be applied to other types of contaminants?
Well, the sampling that we had to follow in the GEMAS project was specified in the REACH regulation. The 0 to 20 was for the agricultural soil because of the sort of normal plowing depth, and the grazing land soil, the 0 to 10, again was adapted for the grass roots. The main part of the grass roots is the top 10 centimeters. So this was a sampling, the two sampling schemes that we have used were essentially dedicated to agricultural soil and grazing land soil. Now, whether they can be adapted for something else, I don't know. I always say if you are going to start something new, you have to carry out an orientation survey. This is the key that everybody forgets. We used to use it in mineral exploration in the old days. I still use it whenever I go to a new area and there is something that I don't understand. Instead of just going in and taking samples without an orientation survey, I think is silly. So you have to carry out an orientation survey. Of course, it does take some effort and resources, but if you want to have good results adapted to the what you are looking for, you have to carry it out. Have I answered you, Ariadne?
Yes, definitely. Yeah.
Thank you. Has anyone else got a question? I've got a little. Oh, sorry, Gloria. Please.
Hi, Alekos. I am Gloria Prieto and everybody from
Hello, Gloria. Nice
Colombia.
to hear you.
I don't want to ask a question. I want only to congratulate to this presentation to Alekos. And I think the best for us, for other countries like Latin American countries, is to divulgate, to spread this kind of research only for encourage young people to do the same in their countries, because at last each country have to have results to bring to the planning people some data to plan every activities. But unfortunately, many people in our countries don't understand the importance of this kind of research. So perhaps if the courses, the divulgation of this kind of results is wider, perhaps the young people find the way to look for budget to do this kind of work. Thank you and congratulations again, Alex.
Thank you, Gloria. I think what we should do is to have webinars for politicians or decision makers. We have to be more simple as well.
Yeah. I think that Alex could be both because in many places the voice of foreign people is important, but also if our young geoscientists are convinced of this kind of research, they I think that can do plan and get for budget, because the budget is very important in this kind of projects. Thank you.
Yes, something I did not mention. Now, the sampling was paid by the geological surveys. Each National Geological Survey or university paid for the sampling, and also the sample transportation from the home country to Slovakia. Now, we had a budget from Eurometax, which was about almost €1 million for the analysis and sample preparation and purchase of all the materials that were centrally purchased and distributed to all participating countries. Now, unfortunately, we did not have €120,000 to analyze for the platinoid elements. This is something I forgot to add as well. Yeah, because we needed a special technique for the platinoids. Unfortunately, we needed €120,000 for this.
Yeah, it's quite remarkable sort of method to secure this great data set. So the cooperation, collaboration that is tested when you have to apply resources to it is a good example. Did anyone else have any questions? I've got a little sort of follow on. I was intrigued by the sort of urban gold anomalies.
Yes, we all
particularly in Scotland. It was in Edinburgh.
Yes, there was also, I forgot to show, yes, Edinburgh, and it goes towards Glasgow.
Yeah, but that's quite far away from any known gold exploitation in Scotland.
That's right.
So I just wonder if it's, well, I suppose there's always the wealth of the capital city of the country, perhaps. All the broken pieces of jewelry over the years.
That's right. Yeah. Yeah, I mean, this is, let's say this is a fossil signature, you may say. So it goes back, but we were surprised as well for this, so.
Fantastic.
Anyway, this year we are celebrating the 10th anniversary from the release of the 2 volumes. And we are going to release all the analytical data sets. Of course, they were available when you buy the volumes, but now we are going to release them to the public. Now, Bob wants to ask something.
Yeah, Bob, please.
Yeah, I have a memory. I think it was in Norway, of a study which showed a gold anomaly around in cities related to crematoria.
Yes.
So here you've got gold in people's teeth going up in smoke. So it's another one of these things that might be worth bearing in mind when it comes to interpretation.
Yeah.
And also, where they use, for our teeth, they use mercury amalgams. Remember, Bob?
Oh, yes.
So,
Silver gilt.
That's right.
Yeah. And what was it? The hatter's disease, because they used to use mercury making top hats.
Yeah, yeah.
A very interesting talk, Alikos. I enjoyed it very much. Thank you.
Thank you very much. Thank you. It was a pleasure to see you again.
Okay, we're coming towards the end of sort of the hour session that we have booked for this, and I'll have a last chance for anyone to ask any final question. Okay. Great. Well, thank you very, very much, Alikos, again for your
My pleasure.
contribution. It's always a pleasure to listen to you, and yeah, certainly makes you sit and think what you could do if you put collaboration at the front. So a fantastic fellows presentation, and thank you very much. And thank you everyone for joining us online, and hope to see you at another one of these seminars or at our SCGH conferences in the future in Africa this year. And I'm not sure what the following program is, but please do join us face to face as well as virtually. So thank you very much, Alikos, again, and thank you everyone.
Pleasure.
Thank you.
Okay, bye-bye.
Bye-bye, Gloria.